Okay, so we're talking about significant figures and then, of course, scientific notation. So, a couple of rules that I want you to learn. Some of them you will definitely need to write down. These first couple, I would write them down because they can get confusing. If you want to listen to the whole video and then go back and write the rules down, whatever you want to do. Okay, so first one. All non-zero digits are always significant. So if you've got a number that doesn't have a zero in it, it's significant. Okay, so how many significant digits are there in the following number? You've got 2, 7, 4. None of them are zeros, so you've got 3 significant figures. Okay, and this one, 2, 5, 6, 3, 2, you've got 5 significant figures. 8, 9, 8, 7, 4. Right, rule 2. All zeros in between the significant figures are also always significant. Okay, so if they're in between, always significant. How many in this one? Well, 504, so you've got 3. So you count them all as significant figures. 60,002, so you've got 1, 2, 3, 4, 5. Okay, 9.077, and you've got 4. So if they're in between, squashed in between, they become significant as well. Right, rule 3. All final zeros to the right of the decimal are significant. Not the left, to the right of the decimal. So how many in this one? So to the right of the decimal means that it's significant. So now there are 3 significant figures. 19.000, so that last 0 is significant. Okay, 5. And then 105.0020, so you've got all of them there for 7 significant figures. Okay, rule 4. All zeros that act as placeholders are not significant. So let's look. Another way to say this is zeros are only significant, A, if they're between the significant digits, or they're the very final thing at the end of a decimal. So they're at the end of a decimal, or they're between significant digits, they're important. Otherwise, they are not significant. For example, how many significant digits in this number? So you've got 0.0002. So you've only got 1 significant digit, okay? Because those here are placeholders. And we don't have one right on the very end, okay? Over here, we've got 3 significants because they're in between 2 significants, okay? Now look at this one. This one I found very interesting. This was 6 significant digits because this digit is on the end and it's between 2 significant digits, okay? So then we're counting it. 150,000 has 2 significant digits, okay? Because that 0 here is not to the right of a decimal, okay? And this one is 1 and 2. That's what we're going to count. 800, we've got 1 significant digit, okay? They're placeholders. These are placeholders, okay? Okay, these rules, so those are the rules as far as significant numbers go. When you're rounding these numbers, the rules are pretty similar to what you would do in normal rounding. So listen to this. If the digit to the immediate right of the last significant digit is less than 5, do not round up. You normally do that anyway. For example, let's say you have 3 digits, so you've got 4382 and you want 3. So 1, 2, 3 is your significant. That 2 is not strong enough to change the 8, so it dies and that's it. And you're left with the 43.8. So the last number you want is the 8. The number to the right of the 8 is a 2. Therefore, you don't round it up. The number is 43.8. Okay, so you know that one. If the digit to the immediate right of the significant number is greater than 5, remember then it's powerful, you round up the last significant figure. So let's look at this one. 234.87, and they say they want 4 significant. So it's 1, 2, 3, 4. So they want the number to stop at the 8 point. But that 7 is strong. So that 7 gives all its power to the 8. The 8 becomes a 9, and the 7 dies, okay, because it gave all its power away. So your last number would be 234.9. Okay, next one. If the number to the immediate right of the last significant is a 5, and that 5 is followed by a non-zero digit, round up. Which 5 is one of the strong ones, so you would anyway. So you want 3 significant figures. You've got a 5 next to the 6. You want that 6 to become a 7. The 5 and the 7 will then die. Okay, so it'll be 78.7. You want the 6. Well, it's on near a number, therefore you round up 78.7.